1 minute. Okay, so we already saw that we need chlorophyll in order to perform.
Chlorophyll, it gives the plant green, ma'am.
Yeah, you were there when I taught you all this, right? Okay. So why do you need chlorophyll? Only for the green color? You need it for what?
It captures sunlight.
It captures sunlight. All right. So here we need chlorophyll for mainly for photosynthesis. Without chlorophyll, there can be no photosynthesis. That is why only green plants make their food. Non-green plants don't make their food. All right. Okay. So now we're going to prove that the chlorophyll is there present in the leaf. Okay. How we're going to do that? First, this experiment is known as, wait 1 minute, I'll just write today's date. It's known as the iodine experiment or the iodine test. Okay, do you know how what iodine drops look like? This is how iodine drops look like. 1 minute. Okay, so iodine drops look something like this. All right, so what you're going to first do is, first thing, you have the leaf. You're going to remove the chlorophyll. How will you remove it? You'll like gently take a coin or take a stick or take a knife. Just scratch the leaf. Just remove the green pigment from the top of the leaf. Don't tear the leaf. You just gently do it on top. Okay. So for example, I'm just removing the green pigment from the leaf. Okay. So I've got all the green pigments over here. Okay. So this is more of a light green right now. Okay. Since I've removed the chlorophyll. Okay. If there's any doubt, just ask me once I'm done with this. Okay. So once you have removed all the chlorophyll from the leaf, after scratching it, what I'm going to do is I'm going to boil it. Okay, so putting it in a vessel and I'm going to boil it. Okay, so you boil itself, how the chlorophyll will come out. Okay, so after boiling it, where am I going to boil? I'm not boiling it in water, I'm boiling it in alcohol. Okay, alcohol is a strong agent for removing chlorophyll. All right, and then what I'm going to do is I'm going to add 2 drops of iodine. Okay, 2 drops I'm adding iodine to the leaf. Okay, the chlorophyll removed leaf. Okay, and then what you can do is when this chlorophyll is being when the 2 drops of iodine is being placed on top of the leaf, what happens? The color will change. Okay, the leaf color will turn blue. Okay, it turns blue in color. If it's turning blue in color, it means there is starch. What is starch? Do you know what starch is? Have you heard this term anywhere?
Yes, ma'am, but I don't know the exact meaning of starch.
Okay, you can just try if you want. It's nothing but sugar. Okay, it is like the raw form of sugar. Okay, so starch is the basic food substance for the plants. Okay, so it shows that this experiment shows that yes, chlorophyll is the storehouse. It is the storehouse of the plant because all the main food is being stored in the leaf. All right. So this starch is actually what happens. This rather than saying blue, you can say that it becomes transparent. Okay, I'll just show you the images for it. See, over this you can see there's like small white patches. Can you see in the blue leaf? That white patch is the transparent area. Okay, I think this you'll understand better. Okay, so first they're boiling the leaf in water, and then they're boiling it in ethanol. Ethanol is nothing but alcohol only. Okay, and then you're washing the leaf, and then you're putting starch test with iodine solution, and you will get the change in color. All right. Any doubts so far? Did you understand?
Yes, ma'am.
Tell me.
This whole process.
Tell me, Ra. Any doubts you have?
No, no.
Okay, fine. Okay, so so you can clearly see that photosynthesis takes place in leaves also. So have you seen any green slimy patches in the ponds or in the stagnant water bodies? Have you seen them? Like
No,
when you go out anywhere, like you see any pond, there'll be small green things on top of the pond. Have you seen them?
no, ma'am.
You've not seen them. Seriously, it's there everywhere. Okay, if you have a slice of bread in the fridge for a long period of time, or you're keeping it out for a long period of time, it gets spoiled. Green patches start growing on it. Have you noticed that?
Yes, ma'am. I noticed it.
What is that green patch?
Ma'am, is it like bacteria?
It's grown because of bacteria, but it's not actually bacteria. So they are known as algae. Algae. Okay. So this algae, what color is it?
Green color.
Green. Why do you think it is green in color? Normally, if a leaf is green, it's because of what?
It's because of chlorophyll.
Very good. So this has chlorophyll. All right. So they contain chlorophyll, which gives them the green color. So can they make their own food?
Chlorophyll. Yes, ma'am. They are green.
Very good. So anything that's green and it's a plant, it can make their own food. So yes, photosynthesis also occurs. Okay. So just they are like slimy green plants. Okay. So we saw what algae is now. All right. So now we're going to see synthesis of plant food by, like, you know, there's synthesizing carbohydrate. Starch is carbohydrate. Okay. Starch is nothing but sugar. Sugar is nothing but carbohydrates. So other than carbohydrates, what does these plants make food? We're going to see. Okay. So we know that the plants synthesize carbohydrates through the process called as
What? Plants?
plants synthesize carbohydrates through the process called as. Through what process do they make carbohydrates? That's the whole point of the whole lesson. Carbohydrates is nothing but starch. Starch is nothing but the food. So through what process is the food made? Hello?
Yes, ma'am.
Through what process do the plants make the food?
Through photosynthesis.
Photosynthesis, that's what I want. Okay. So we know that the carbohydrates is made up of what and all the starch is being made up of? It's made up of carbon dioxide, it's made up of oxygen, and with hydrogen. Hydrogen, we get it from where? We get it from water, right? So these are used to synthesize other components of food, such as proteins and fat. So if they use these all three, you will get carbohydrates. So mix matching the components, like I told you, no, these separately are known as what? They're known as ingredients. I already taught you last class. Okay. So these are the ingredients for making starch or carbohydrates for the plants. So when mix matching the ingredients, like for example, you're going to make chicken curry. For chicken curry, what are you going to put? You're going to put chicken, you need chicken stock, you need salt, you need pepper, you need chili, right? So this is called chicken gravy. You put water, everything, you make a chicken gravy. And same thing, you remove the chicken, you're putting paneer, it becomes paneer gravy, right? So if you change the ingredient across the ingredients, what does it become? It becomes a different dish, right? So these three important ingredients are mismatched with each other to also give other food other than carbohydrates, that is proteins, fats. So plants make proteins and fats also. So, but proteins, they are nitrogenous substances. Okay, they contain nitrogen. So substances that contain nitrogen are known as nitrogenous substances. All right. So, but the proteins are nitrogenous substances which contain nitrogen. So, where does the plant get nitrogen from? Only carbon dioxide is there, oxygen is there, hydrogen is there. But from where is the plant getting nitrogen? Can you think and tell me?
The plant is getting from.
Okay, all right. This is a bit hard only, but you know that the air, there is no, what are the components of air? What else is there other in the air? Carbon dioxide is there, oxygen is there. What else is there? What else is there in air?
Ma'am,
Tell me.
ma'am, hydrogen is it?
Okay, hydrogen is there. Nitrogen is also there. Okay. So you have carbon dioxide, oxygen, hydrogen, nitrogen. You have smoke, you have pollutants, you have so many components that is there around you, right? So we know that this carbon dioxide, oxygen, and hydrogen is being directly absorbed by the which part of the plant? Which part absorbs all these of the plant?
On the leaves.
The leaves, very good. So the leaves are being absorbing all this because of the presence of chlorophyll. Even the stem and all will absorb because even they have chlorophyll. That is why they are green in color. Okay, but they cannot directly absorb nitrogen. Okay, so how will the nitrogen go inside the plant only? We're going to see. Okay, so first there is a lot of air components. So you have H2, O2, sorry, you have CO2, N2, smoke, pollutants. So all this constitute is known as it's known as what? All this together only makes air. Okay, air has all this. Okay, here nitrogen alone, it's taken up by the roots. In the roots is submerged in what? Root. Sorry?
Using submerged.
Yeah, the roots is present where? What is surrounding the roots? Where is the root present, Ra? What is surrounding the root? What is this dot dot thing I'm drawing? Is the root inside water? It's inside what?
Inside soil.
Soil. Okay. So this soil will absorb the nitrogen and it will send in nitrogen through the roots along with water. So nitrogen plus water will go inside the plant. All right. So nitrogen is present in abundance in the gaseous form in the air. Okay. However, the plants cannot absorb nitrogen in this form. So the soil, what it does, it has certain bacteria that will convert the gas into a useful substance. So here, carbon dioxide, hydrogen and all can be directly absorbed by the leaves of the plant. But nitrogen cannot be directly absorbed. Like why I'm saying that, for example, you eat non-veg, right? Hello?
Yes, ma'am. I do.
Oh, so for example, you're going to eat chicken. What will you do? You're not going to just go get chicken from the shop and start eating, right? What you'll do, you'll first buy the chicken, you'll wash it, you'll cook it, and then only eat, right? So you can't directly absorb it. Similarly, nitrogen cannot be directly absorbed by the plant. There should be other ways where they're converting the nitrogen into a more absorbable form so they can use it. So what they're going to do is the soil is going to convert nitrogen in a more simpler form. Like for example, if the nitrogen molecules are like this. You know what is a molecule?
Yes, ma'am.
Okay.
Very small particle.
Yeah, so if the nitrogen, for example, this is only example, okay? Like this means what does the soil do? So this is the nitrogen in air. So in soil, there is certain bacteria, which is I'm drawing in red color. So the certain bacteria, what they will do? Bacteria in soil. They will convert nitrogen in a more simpler form. Okay, when they are separate molecules, you can easily like observe it. Okay, in more simpler form, and it will send it through the roots into the plants. Okay, so what are the other ways that the nitrogen is being absorbed is they are like 1 minute. Hello, sir, I'm in the middle of the class, sir. Good evening, good evening. Yes, sir, I'm taking class right now. Yeah, 1 minute. Yeah, admitted, sir. Yeah, okay. Thank you, sir. All right. So this thing is being, you can see nitrogen is being taken. Varshit, next time please be on time, okay? Because I'm being sharing my screen, so I won't be able to see if you're waiting in the hall. Okay, I'll be taking sharp by the time I am saying. That's why I'm joining 10 minutes earlier itself. Okay. All right. So this nitrogen is being taken along with water through the plants. All right. So that is why you would have seen that to increase nitrogen richness, what the farmers do? They use nitrogen-rich fertilizers. Okay, note down the homework question. This is the homework question. Why farmers use nitrogen-rich fertilizers? Okay, note it down. Okay. I'll just give a sum up of what I thought so far, Varshit. By the time you can you can make the notes down. Okay, Kritvik, just take notes down of whatever I thought so far. By then that, Varshit, just listen now. So I'll just brush up. So we have learned in the last class that the leaves are rich in chlorophyll, which help in the process of photosynthesis, that is making of their own food. Okay, so in this leaf, you know, the leaf is known as the food factory, right? So why is it called the food factory? All the food is being stored in the leaf only. Okay, so we are going to see if this is true or not. Okay, so we're going to do an experiment and check if this is true or not. So what is this food that is being stored? The food that is being stored is known as starch. Okay, starch is the food that the plants make. Starch is nothing but it's carbohydrates. Okay, carbohydrates are made from carbon dioxide, oxygen, and hydrogen. Okay, so you can see separate components over here, over there. Similarly, like when you're using cooking, you're going to use salt, pepper, and everything, right? So they are known as ingredients. Similarly, here for carbohydrates or for starch, both of them are same. The ingredient here is carbohydrates, oxygen, and hydrogen. All right. So where does the hydrogen come from? It comes from the water. So what experiment we're going to do is we're just going to take a leaf. We're just going to remove the chlorophyll like by simply scratching it with the help of a knife or just gently scratching it. We're going to boil it in alcohol, that is ethanol, okay, which is a type of alcohol only. So once you boil it, it becomes like a slight transparent color. Okay. So in the transparent leaf, you're going to add 2 drops of iodine. Okay. When you're adding iodine, it turns a transparent color. Okay. So a not exactly transparent also, it's like a bluish black color. Okay, wait. Take turn. You have test right now, right? You sit and revise. I'll give you a test. Give me 5 minutes. Okay, so it becomes bluish black. So you know what is a litmus test?
Yes, ma'am.
Okay, so there also you know that the acids are turning. Acids turn what in color? It turns
Blue.
red, right? Acids turn red. Okay. So acids turn red, bases turn blue, right? So similarly here, this is also one of the indicators, that is iodine is an indicator where the leaves turn bluish black in the presence of starch. Okay, if they react with starch, it turns bluish black. So since it's turning bluish black, you can say yes, there is starch in the leaf. Okay, so other than carbohydrates, there are also other things that the plants make as food. That is proteins and fats. These proteins and fats are made with the help of nitrogen. Okay, so how does the plant get nitrogen? Only carbon dioxide, oxygen, and hydrogen is being present. So we know that in the air, there is a lot of other components also. That is hydrogen, carbon dioxide, hydrogen, smoke, pollutants, nitrogen, all these are there. Okay, so this nitrogen in the air, you know, like if we're getting food, like if you're getting if you're getting pasta, you're going to buy pasta, you're going to boil it and then eat it. You're not just going to buy pasta, the dry pasta, and eat it, right? You're not going to do that. You're going to boil it, cook it, and then eat it. Similarly, nitrogen cannot be directly consumed by the plants. Instead, they have to be converted into a simpler form. Like here, you can see in air, it's present like this. They convert it into a simpler form with the presence of bacteria that is in the soil. Okay, this bacteria, they convert nitrogen that is abundantly present in the air, and then it is taken up by the plant into the root along with water. Okay, so this is how nitrogen is taken inside the plant. Okay, so for this purpose, what farmers do, they use nitrogen rich fertilizers. All right, so there is also a green component that is present. You have seen in many ponds and all, there is all this green dot or things on the water. Okay, even if you keep bread for a long period of time, if it gets spoiled, what it becomes green kind of thing that is growing on top. That green substance is known as algae. Okay, they are slimy green plants that grow in the presence of moisture. Okay, so why are algae green in color?
Because of the presence of chlorophyll.
Very good. Toothbrushes have chlorophyll. So if they have chlorophyll, they can automatically make their own food. That is through photosynthesis. All right. This is what has been covered so far. Take 5 minutes, take a note down of everything, and ask me any doubts after the 5 minutes. Okay.
I'm done.
Both of you have noted it?
I'm done.
Okay, any doubts? Both of you? Any doubts? Students, I'm asking you, any doubts?
I'm not having any.
Okay. What about you, Varshit? No doubts?
Yes, ma'am.
Okay, Varshit, just give me 1 minute. I'll do this for now. If there's any addition question, I'll give. Okay, 3 questions are given. I'll give you the answer.
I'm not giving the marks yet.
My screen is visible, right?
Yes, ma'am. Visible.
Okay, I hope you've noted down the homework question. Note it down, right?
Yes, ma'am.
Okay. So now, what are the other modes of nutrition? So we saw that we saw 2 modes of nutrition right now. So what is nutrition? We saw last class. Varshit, tell me what is nutrition? What is nutrition? That is the lesson's name, nutrition in plants. What is the meaning of nutrition?
Ma'am means food. Energy.
Come again.
Ma'am, which is any substance which gives energy.
Okay, that is nutrition. Kritvik, can you try? Dinner. Can you try, Kritvik? What is nutrition?
Ma'am, ma'am, should I give like any 2 points?
Yeah, tell me.
Ma'am, it's there in food and it happens in utilization of.
Exactly. That's the word I want. It's the utilization of food. See, taking enough food and utilization of food. Okay. Please take good notes of whatever I'm teaching you all. Okay. Because everything is there in my notes. That's why I'm giving you a lot of time for taking the notes down. Okay. To note down everything that I'm teaching you. So taking enough food and utilization of food is only called nutrition. And why we need nutrition only? You should say that we need to grow, we need for energy, and we need to do our everyday work, giving us strength and everything. Okay. So we taught 2 modes of nutrition. So we know that nutrition means it's the process of taking enough food. So we saw 2 ways of taking enough food with the plants. What is it? What are the 2 ways we saw? Wasn't present. So Kritvik, you tell me.
Ma'am, what is the modes of nutrition?
Yeah, 2 ways the plants take in the ingredients. We saw 2 ways. What is that?
Ma'am, ma'am, they absorb nutrition from the leaves.
Very good. One is through the leaves. The second one?
And ma'am, through the roots.
Very good. That is the nitrogen that we saw over here through the roots that is present in the soil. Okay. So now we're going to see other modes that the nutrition is being taken by the plants. Okay. So there are some plants that do not have chlorophyll. Okay. That is the non-green plants. So we know that they cannot synthesize food. So how will they survive otherwise? So you know that they don't have chlorophyll. If they can also not make their own food. So how will they survive?
On depending on other plants.
Very good. So non-green plants. We know that there is no chlorophyll. So what they do is depend on other organisms for food. All right. So similarly, like how we humans and animals, we depend on the plants for food, they also depend on other organisms for food. So this kind of nutrition is known as heterotrophic nutrition. I'll give you time. Don't take note of anything right now. So this type of nutrition that is depending on other plants or other animals or other organisms is known as heterotrophic nutrition. All right. So the ones that make the plants making their own food, that nutrition is known as
Autotrophic nutrition.
autotrophic nutrition. Okay, I think I already mentioned it somewhere. Did I? Yeah, see, I already told you. Heterotrophs, they depend on others, whereas autotrophs means self-nourishment. All right. So heterotrophic nutrition. So there is this portion, for example, if you have a money plant or any climber you would have seen in your house, if you're having garden or anything, you can see some of the stems are yellow in color. Okay, that means they are getting out of nutrition. Okay, so if green plants are turning yellow, what will happen? That means the chlorophyll is less in them. So when they're changing water, or if you're giving them fertilizer or proper watering of food and all you're putting for the plant, then they turn green again, right? So this is how you regrow a dead plant. All right, this is all basic knowledge. Okay, so sometimes you would have seen that there is a yellow wiry branch structure that is twining around the stem and the branches of a tree. Like, I'll show you 1 minute. Have you seen mangroves, like groovy plants and all? Have you seen such plants like this, what I'm showing right now?
Yes, ma'am.
Okay, so these yellow wiry plants or branches that is around the trees is known as cascuta plant. Okay, I'll just get an image. Okay, so this wiry plant is known as cascuta. Okay, so you can clearly see why is it yellow in color?
Because chlorophyll is less.
Chlorophyll is less or chlorophyll is not present. Okay. Okay, so chlorophyll is not present. So it doesn't have chlorophyll. So it takes ready-made food from the plants that is climbing. So what it's like for example, there is a dead man or a no nutrition or a weak man. Okay, and there is a healthy man. Person is healthy, this person is weak. It's like the dead is feeding on the healthy. It's like that. Okay, like the tigers and lions, they eat dead meat, right? Dead zebra, dead animals that they eat. Similarly, this cascuta, since it doesn't have enough chlorophyll or enough nutrition, it climbs on the green plant and it will drain all the nutrients from the green plant. Okay, that is how cascuta is function. Okay, it takes ready-made food from the, so you can see that the plants, normal green plants, what they have to do, they have to first store the carbohydrates, sorry, the carbon dioxide, the hydrogen, the oxygen from the leaves. Then they have to use sunlight. They can only do it during the morning, that is photosynthesis, and nitrogen for is taken by the roots. So they have a lot of process that you have to go through in order to make a proper starch or proper carbohydrate, right? But this cascuta, it need not do anything. It just gets a green plant, it gets ready-made fruit from them. It need not go through all this process. Just kill the green plant, take the food from them. That is what cascada does. Okay, so the plant, so similarly, can you tell me similar? Now here I told you cascada, I also gave you an example of zebra and lion and all. Can you give me another example where the dead or the weak is feeding on the healthy? Can you give me another example? Let me see how creative you guys are. Give me an example of where the weak feeds on the healthy. I can give you one clue. It happened a year back. This situation happened a year back. That's the clue.
And COVID-19.
COVID, exactly. So what this COVID bacteria is doing? It is weak. Okay. So what it does, it attacks the human beings and it is feeding on the human, killing the human. Okay. So other than saying COVID, you can say bacteria and viruses.
Okay, ma'am.
All right. So this bacteria, these are all examples, okay? So you can see cascata is dependent on green plants, or it's feeding on green plants. A lion is feeding on zebra. Bacteria or virus feeding on humans. So you can see that all these are weak or parasitic creatures, whereas all these are healthy creatures. Okay, so these organisms on which the parasites or the unhealthy ones depend on are known as the host. All right, so here we are the host. Okay, if the bacteria is getting into a body and feeding on us, we are the host. Okay, since it deprives the host of valuable nutrients, the cascada plant is known as, these all are known as the ones that feed on the host. Okay, the organisms that depend on the host is known as parasite. Okay, so this is the definition. I'm not writing the definition, so listen carefully for you to take the notes. The organisms that depend on other organisms for direct food consumption is known as the host. Okay, the depending one, the one on which it depends on, is known as the host. Okay, the organism that is actually depending on the host is known as the parasite. Okay, the organism that deprives or it sucks all the nutrient components from the plants is known as, plants or animals or other organism is known as the parasite. All right, so have you seen or heard of plants that eat animals? You normally have heard animals eat plants, but have you heard plants eat animals?
Yes, ma'am.
What is a plant?
Pitcher plant.
Pitcher plant. Very good. So it's not only pitcher plant. What's the other thing? Only pitcher plant is there?
No, ma'am, more are there.
You have pitcher plant, you have Venus flytrap. Okay, so you have like these different plants. I'll show you a video of how it works. Okay, so what these plants do, they are also like almost like mild green color, but they don't have chlorophyll, so they have to depend on other organisms. Okay, so there are few plants that can trap the insects and they can digest them. Okay, that's great, right? How can a plant do that? Such plants may be green or it can be some other colors also. Okay, so so there are plants that eat animals. So the example, pitcher plant. Okay, now here can you tell me which one is the host and which one is the parasite?
Ma'am, plant is the parasite and the animal is the host.
Very good. So plant is the parasite here and animal is the host here. All right. So this is, for example, pitcher plant, and you also have Venus flytrap. All right. So I'll just show you how a pitcher plant looks like. So this is how almost a pitcher plant looks like. Okay, it's like a big jug kind of thing, and inside the jug there is a liquid that is like nectar or honey. Okay, it's like a sweet substance. Okay, it's not like the normal honey that you get from the plants, but this pitcher plant has a different type of honey. Okay, so what this does, when a bee or an insect, okay, it comes, it tries to get the nectar from the plant. Okay, and what it does, it will fall inside and the plant will kill the insect and eat the insect. Okay, this is a pitcher plant. Whereas in Venus flytrap, you would have seen a lot of videos also. It's like a open close flap kind of thing that they have. Okay, so this is like an open Venus. Okay, so this open, what happened, this insect will go and sit inside. Okay, when it goes and sits inside, what happens, the Venus flytrap will close itself. It will go, so it's an insect is inside. Okay, it will die. All right, so this is a pitcher plant. This is Venus flytrap. All right, so inside the pitcher plant, so you can see that the pitcher plant looks like a jug-like structure. Okay, that is almost like, if a jug, if you convert it slowly, it becomes like a leaf kind of structure. Okay, so this is like the whole body of the plant. Okay, so the apex of the leaf, this part, it forms, what happened?
This is already in 12 p.m. and 12 a.m.
Yeah, both are different.
But it only is in 24 hours now.
Yeah, it will be different only, more than think. Okay, so the top portion, it's like modified into a opening kind of thing. Okay, it's like a form of a lid portion. Okay, you know it's a lid, right? Like a cap. Okay, so inside the pitcher plant, there is some hair that is directed downwards. So you have certain hair kind of like hair like this. Okay, in a downward direction. Okay, so when the insect lands on the picture, the lid, what will happen? It will close. Okay, and it will trap the insect and it will get collapsed in the hair. Okay, it will get cashed up in the hair and it will fall into the honey and it will kill. Okay, the lid closes, the insect is trapped, the insect is digested by a digestive juice. So this honey is the digestive juice of the pitcher plant. What is the digestive juice of us human beings? HCl, hydrochloric acid. Okay, you will learn that in the upcoming lessons. Okay, so in our stomach also we have certain liquid for digesting our food that is known as digestive juice. Similarly, the pitcher plant also, it has a digestive juice for helping it in digestion. It is known as, that is the digestive juice of the pitcher plant. Okay, so the insect is then digested by the digestive juice that is secreted in the pitcher plant and its nutrients all is absorbed. Okay, these kind of insect eating plants are known as insectivorous plants. Okay, so such plants are known as insectivorous plants. Okay, so I'll just show you the video of how a Venus flytrap is, and then you can start taking notes. So this is how a Venus flytrap actually looks like. See, it's like a pocket kind of thing, and the insect will go and sit inside and it will close.
The Venus flytrap.
You can see in the video on the heading itself, it's given Venus flytrap snapshot on a host. Okay, the host here is what? What is the host here?
Ma'am, here flies.
The flies. The video is visible, right?
Yes, ma'am.
Like the sundew, it makes itself very attractive, oozing nectar across the brim of each leaf. But any visiting insect had better watch out for these 6 tiny hairs.
So these tiny hairs that you see on the Venus flytrap, they are like poison. Okay, so if they prick the insect becomes unconscious. He's
This
getting
fly
stuck.
has to tread carefully. If it strikes one hair, it can carry on feeding, but a timer has been set.
Okay, it's like there's honey on the top of the Venus flytrap. So in order to feed on that, the insect is coming. So it's like a small, you would have seen in movies and all, no? Like in there'll be red laser light radars. So you touch one laser, they'll bomb you, they'll kill you, right? Have you seen that in movies?
Yes, ma'am.
So similarly, these 6 kind of hairs, they're like radars. So you disturb them, you're gonna get trapped inside. Okay.
A second strike in less than 20 seconds, and the fly is doomed.
You see, it touched it, right?
An electrical impulse is triggered, and the leaf snaps shut in just a fraction of a second. The tips lock together like prison bars.
See, they're showing it again. It's touching the radar thing.
If the fly is very big or very small, it may just manage to escape. But most are trapped.
If they're very big, they can escape. But if they're
And
small, they
die.
cannot do anything. See, the poor insect is dead now.
10 days later, the trap reopens.
After 10 days, the Venus flytrap will open. So you can see the insect is green, like almost gray in color. It's a dead body now. You know, like human dead bodies, they turn blue, right? If you leave it for a long period of time. So after 10 days, it will slowly feed on the insect and it will open itself.
All that remains is a husk. The plant has finished its meal and resets itself for its next victim.
Okay, I hope it is clear.
Yes, ma'am.
Any doubts you guys had?
No, ma'am.
No. All right. So take a note down of all these.
Okay.
There's also another homework I'm giving. Can you tell me if you're done with noting it down? 1 minute.
Ma'am, I'm done.
Done, ma'am.
All right, then I hope you have taken all the questions down for homework. 2 questions I've given you. How is the why is the farmers using nutrition-rich fertilizers, and also how the Venus flytrap works for gaining its nutrition. I hope both of them are noted down. I'll be asking you all questions of whatever I taught so far. All right, any doubts you guys had so far?
No, ma'am.
No, ma'am.
Okay, fine. I'll see you next class, then that will be day after tomorrow, same time. Okay.